Hello everyone, this is BK Barik from the channel Physics Concepts. Today in this video I will be teaching you another topic of class 10 students, that is your variation of kinetic energy and potential energy with height above the ground. In my last video I have taught you the law of conservation of energy. In that we have seen that when the body was falling freely under the action of the gravity, the total mechanical energy was conserved and the total mechanical energy was constant. That was here the initial potential energy, that was mgh. So today I will be showing you the graphical representation of the total energy or the kinetic energy and the potential energy when the body falls freely under the action of the gravity, where there is no force of friction. Remember that in this equation we are neglecting the force of friction acting on the body due to air. So let's see here. In my previous video I have given you must have known that, say this is the ground, this is your ground, and the body is placed at a height say h. This is your at a height that is h above the ground. So height from here to here, that is h. Say this is your position A and this is your position C, and in between one position I am taking, say this is your position B. Say the height of the B from the ground will be h by 2. So this height will be a h by 2, and this also remains here h by 2. This is position A, position B and position C. At position A, the body was having the potential energy only, that is U is equals to mgh, and the kinetic energy was 0. At position C, the body was having kinetic energy, that is K is equals to mgh, and the potential energy was 0. Since we have considered this point was on the ground, it is exactly not on the ground, just little bit above the ground we are taking. And the point B, if it happens to be exactly at the center between A and C, therefore I have considered here height of the B from the ground, that is from point C, will be h by 2. So here the total energy is how much? That is mgh. So therefore the kinetic energy was here half mgh, and the potential energy is also half mgh. So that the total energy was appearing over there mgh. Now let us see this part in the form of the graphical representation. Now follow this graph. I am drawing the graph for you. You see over there. So this is your y-axis. This is your x-axis. This is your y-axis. So in the y-axis we are taking energy. It is increasing in this manner, and here we are taking height above the ground. This is your height above ground, and the height is increasing. Your height is h, it is increasing in this way. So we have taken as for the point, this is your point A and this is your point C, and in between we have taken another point, that is your point B. Okay, now see in the graph and see this diagram also. From the diagram it will be easy to plot the graph. At point A, what is the potential energy? At point A, the potential energy was mgh. So here we have taken, this is the energy axis, this will be a 0, and say this point will take the energy as mgh. Now see, at point A the body was having what type of energy? It was having the potential energy, that is mgh. Now at point A the body was having potential energy, that is mgh. So here this is again. At point C the body was having what type of energy? What was the potential energy at point C? At point C the potential energy was 0. That means if this will be energy, this is the point, then we will mark over here. We are now marking for the potential energy initially. At point A the potential energy was mgh, at point C the potential energy was 0. So now 2 point is marked already. Now draw a straight line from this point to this point. So this is the curve for the potential energy from point A to point C. So point C at a height, that is how much? Total height, that is HM. From here to here, this total is taken 8. Now see kinetic energy curve. Okay, let's see at point A, what was the kinetic energy? The kinetic energy at point A was 0. So then this will be at point A. The kinetic energy is 0. That means here it will be coming. Now what is the kinetic energy at point C? The kinetic energy at point C is here the total energy, that is mgh. That means at point C the kinetic energy is coming mgh. That means over here, this is the point. Now draw a straight line from point A to this point, point C. This is your kinetic energy. Now see over there, at this point the potential energy is becoming how much? Half mgh. So at this position it will be half mgh. This is your half mgh. And what is the kinetic energy? This is your potential energy curve. I am just writing over there. Potential energy. This is your potential energy. Then which is the kinetic energy? This is your kinetic energy. This is your kinetic energy. Now at this point the potential energy is becoming half mgh and the kinetic energy also becoming half mgh. See over there, this is the kinetic energy from here, from A to C. This point is the C. From A to C kinetic energy is increasing, that means, and from A to C the potential energy is decreasing. Here the potential energy started with mgh. Again at point B, I told you B is the point which is exactly at the midpoint between A and C. At that position the kinetic energy will be half mgh and the potential energy will be half mgh. Why? Because the total energy has to be mgh. So here the kinetic energy is becoming how much? Half mgh, and potential energy is becoming how much? Half mgh. And at this position the body is placed at a height h above the ground. That means h by 2 above the ground. This is your position A. Position A from C is at height h. This position we can take over there h by 2. So this is your position B. Now we can consider this is the position B. So at position B the height is h by 2 and the kinetic energy is half mgh, potential energy also half mgh. So in this way you will draw the graphical representation of the variation of the kinetic energy and the potential energy for a freely falling body under the action of the gravity. In the same way you can also draw the variation of potential energy and the kinetic energy for a body when it is moving in vertically upward direction. In the same manner you will do. So this is there in the ICSE syllabus, therefore I thought of teaching you. Thank you.